Before we take a look at color correction in Shake, we should take a look at the subject of bit depth, because this can cause artifacts and problems in your color correction operations. So let's load a script. Click on the Load button, click on the pop-ups, go down to the exercise files, Chapter 15, Shake Script 01. Here we have a ramp, and as we can see from up here, it's an 8-bit ramp. Because it's an 8-bit ramp, it has code values from 0 to 255, which gives it 256 unique steps in brightness. However, in this node, we're scaling it down by 0.1. So instead of 256 steps of brightness, we have 1/10 of that now, or call it 25 steps of brightness. In this node, we're scaling it back up by a factor of 10, putting it back where it was in brightness, but we only had 25 steps in brightness to work with. That's why you see the banding. From 0 black to 255 white, we only have 25 steps of brightness, and the eye needs closer to 200 to think it's a smooth gradient. Now we'll take the ramp node, click on the parameter button, come down to the bytes and switch it from 8 bits to 16 bits. With 16 bits, there's now 65,535 steps. So this brightness operation, which scales down to 1/10, instead of having 65,000 steps, there's now 6,500 steps. Then we scale the brightness back up by a factor of 10. We now have 6,500 steps in brightness, which is easily enough to fool the eye into seeing a smooth gradient. So if the number of steps between black and white becomes too few, the eye will start seeing banding. What 16 bits does is it gets you many more steps. In fact, the 8-bit ramp had only 256 steps, but the 16-bit ramp has actually 256 steps between every step of the 8-bit ramp. Let's move over here and double-click on Marcy to put her in the viewer. She's also an 8-bit image. Now double-click on this brightness button, and we have scaled her down by a factor of 20. We're going to see the exact same problem. In this node, we scale her back up by a factor of 20, but you can see as I punch through the red, green, and blue channels, the number of steps of brightness is now very few. In fact, as a 20-to-1, there's about maybe 12 steps of brightness for each color channel. So bad that we can easily see the banding. But we can actually fix this. I'll select the Marcy node. We'll go to the Other tab and click on the Bytes node. The Bytes node offers us the chance to convert the image to what we call promote it, to 8, 16-bit, or float. All we do is click on 16 bits. Boom, the image is fixed. At this point, Marcy was a 16-bit image with 65,000 steps of unique brightness. In this node, she got 1/20th of 65,000, so she had over 3,000 steps in brightness. And in this node, scaled her back to full range of brightness, she still had 3,000 steps, which is more than enough to appear smooth to the eye. Now let's look at a different case. We'll slide over here, double-click on this Marcy, again, 8-bit image here. But this time, this brightness node is going to increase her brightness by a factor of 2. Let's take a look at that with the color picker. You see, scaling up all the code values by a factor of 2 has caused huge regions to become clipped. Code value 255. Down here we still have some code values, but these areas here are just clipped flatter than a pancake. We'll go back to the node view. This brightness node is now scaling the overbright image down by half. However, we'll take a look at that. Using the color picker, we can see those code values are now 128. Once they got clipped at 255, that was it. The data values above that are gone. So when we scaled it back down, you can see horribly clipped regions in the picture. But there's an easy fix for that. We'll select the Marcy node, again the Other tab, we'll add a Bytes node, and this time we'll set it to float. Voila! All of the picture comes back. The reason is the 8-bit Marcy was converted to floating point right here. Floating point converts the images to a data range of between 0 and 1.0. And if the brightness goes above 1.0, floating point will keep it and not clip it. So here, when we doubled our brightness, even though on the display it's clipped, the code values of 2.0 are still retained in the floating point image version. You can see up here it says float. Then in this brightness brings it back down by 0.5. The unclipped pixels came back down below 1.0, and now the image is restored. The only problem is, when you work in floating point, it slows down your computer significantly. In this movie, we saw how bit depth could introduce serious artifacts in our color correction operation. We saw how switching to 16 bits or floating point can prevent the introduction of banding problems and other artifacts.